I'm excited to be here and to talk to you about what I've learned from my experience in psychology and hear about maybe some, if we have time at the end, some similarities and differences to other fields. So I'm just going to jump right in. I've been thinking a lot about what to say in this talk, and I've come up with 9 lessons that I think we can take away from psychology's replication crisis and reform movement. And I should say at the beginning that these are just my opinions. They don't reflect any group that I'm a part of, and they're probably wrong in many ways. But I'm decided to be bold and share some controversial opinions. So the first 4 lessons are going to have to do with transparency and openness, but the whole talk isn't going to be just about transparency. But so the first one is that transparency is necessary for credibility. And, it seems kind of obvious, and it probably was obvious to all of us at one point early on in our education that, in science you show your work, and if someone doesn't show their work, then it's not trustworthy. But at least in my career, I kind of unlearned this lesson as I became more familiar with research practices and kind of adopted the norms of my field. And I had to relearn this. And it was kind of a jarring experience to talk to non-scientists, people outside of academia, outside of research, and explain why we don't show our work, why we don't always share our data. And I remember even in the early days of the reform movement and open science and everything, I was reluctant to share data, even in cases where it was perfectly reasonable for people to ask for my data. And so it's kind of confronting to realize that actually that's just not an okay position to have as a scientist, to say I'm not going to share my data for purely selfish reasons. And this is actually something that is fairly well established. There's an econ paper by a guy who won the Nobel Prize in economics called "The Market for Lemons: Quality, Uncertainty, and the Market Mechanism." It has nothing to do with science or scientific publishing, and I came across it reading about, I don't remember, something in the news. But when I read about the principle behind it, it became very clear to me that actually this is a very obvious phenomenon. That this idea was developed in the context of economic markets, and Akerlof used the example of buying a used car. So a lemon in American English is a bad used car. So you buy a used car, you think it's a good car, but actually it's a lemon. And he used this market to show what happens if there's quality uncertainty. So if the buyer can't tell a good quality product apart from a bad quality product. And he said that in this situation of information asymmetry between the buyer and the seller, he showed mathematically that it leads to a vicious cycle where people lose trust in the market. Because if, as a buyer, you know that there's this information asymmetry, that the seller is withholding information, you know that you're in a position where you can't tell high quality from low quality, then you stop being willing to invest in the market. And as I was reading this, it became clear to me that it's the same thing for scientists, that we are the sellers of our scientific findings, and the buyers may be other scientists or the public. If we withhold information, where there's an information asymmetry, and the buyers know that we're withholding information, they know that they don't have the information they need to tell apart a high quality product from a low quality product, then they're going to stop being willing to invest in the market entirely. And of course, we're lucky that we're not there. There's still quite a bit of public trust in science. But it became clear to me that, we should probably hold ourselves to at least as high a standard as used car salespeople. If you went to buy a used car and you said, "Could I look under the hood?" and they said no, for no good reason, just we don't want you to, you would not trust that seller, right? So if you ask a scientist, "Can I see your data?" or "Can I know more about your process and your procedures and so on?" and they said, "No, I just don't want to tell you. I don't want to share that information," we should not trust them either. So this kind of highlighted to me the importance of transparency and of being able to look under the hood. And of course, in science, we actually have more of an obligation than in an economic market. It's not just a matter of like financial or trust, common, not wanting the market to devolve into a vicious cycle. It's also just a fundamental principle that we show our work. And in fact, that we go bend over backwards to give our critics ammunition, right? We talk a lot about science being self-correcting. Well, the first thing you need if you're going to have a self-correcting system is to make it easy for people to find errors. So that maybe seems obvious in retrospect, but actually it was a hard lesson for me to come to learn and to really kind of go back to that naive perspective of a scientist just starting out and understand how important transparency is. But the next lesson we learned is that once we started trying to change transparency and practices and get people to be more open, it's really hard to change. And so what I'm going to show you now is a little bit of data over the first 5 years or so of psychology's replication crisis. And this is a period where a lot of efforts sprang up to try to increase open science, particularly in psychology. So we got our first preprint server, the Center for Open Science, that was founded by Brian Nosek, a psychologist, became more popular. Many other things happened that were kind of pushing for more openness and transparency. And Tom Hardwick, who I'm going to be talking a lot about in this talk, I'm not presenting very much of my own research. I'm presenting basically Tom's greatest hits. So he's a fantastic meta researcher who's done a lot of work looking for empirical data on the topics that I'm talking about today. So we have a paper that came out a few years ago, or last year, about the prevalence of transparent research practices in psychology. So this was comparing how often articles published in psychology journals have things like open data, open materials, open code, and so on. And so we used data from a previous project of Tom's that was done earlier, and we compared that to more recent years. So for example, for open data, Tom's earlier work showed that a random sample of articles in the whole field of psychology for articles published in 2014 to 2017, so already a few years into our replication crisis, which in psychology started in 2011, but it took a few years to get going. And so by 2014, 2017, we're publishing articles that people collected the data and ran those studies basically before the replication crisis really started. So it's a pretty good baseline measure of openness, and open data was really rare. And then, about 10 years into the replication crisis, it's much higher, right? An order of magnitude higher. So about 15% of psychology articles have open data, a bit higher in prominent journals, actually basically the same, but the prominent journals is based on impact factor, basically. So we can see that with 10 years of really diligent effort by a lot of people and a lot of talk and a lot of panels at conferences and a lot of activism, we got the rate of data sharing, by one way of thinking about it, up very high, right? 10 times more. By another way of thinking about it, still quite low in absolute terms. And we see similar patterns for sharing, for example, the code or analysis scripts. Again, it went up dramatically by one way of looking at it, and still very far from as high as you might like it. Sharing materials, similar pattern, and pre-registration, similar pattern. And you could ask, like, what's the ideal rate here? It's not 100%. There are good reasons in some cases for not sharing data or not pre-registering. But I think that for most of these, it's much, much higher than 15%. So, as much as transparency seems like an obvious thing in retrospect, and it's pretty hard to think of good arguments against basic sharing in typical cases, it's still really hard to get people to do it, even with all of the efforts that have been going on in psychology. So we still have a long way to go to get to, I think, acceptable rates of transparency. So I'm borrowing Brian Nosek's pyramid here of change, cultural change, where he talks about how before you can make something required, make it the default, you have to work up to that by making it easy for people to do it, making it normative, making it rewarding, and so on. So I would say with transparency and psychology, we're around the make it normative, make it rewarding stage. We have good infrastructure for it. We have good communication and training about it. There's good resources if people want to learn how to share their data or write analysis code in a way that's understandable to others and so on. We're still kind of in the growing pains of it. It's not a part of everyone's training. There's still some obstacles to it, but we're getting there. And so that brings me to my next lesson from Psychology's Crisis, and this is maybe where it gets a little bit controversial. My experience with kind of being part of this change and seeing what happens as we're going up this pyramid is, in the beginning, we were worried about rushing too fast. Like we knew that we can't just jump to making it required before people know how to do it and understand the value and have the support and so on. But now I'm worried about going too slow up this pyramid. And I think that one important lesson I learned is that we should actually try to hurry up and get to that make it required stage. And let me tell you a little bit about why I'm thinking this way. So basically what it boils down to is, in my experience, if transparency is optional, the incentives will always favor those who opt out. And there's almost nothing you can do, or it's hard to imagine what you could do to offset those incentives. So let me give you an example. In my role as journal editor, for most of my career as journal editor, most of these transparency practices have been optional for authors. And so we're often in a position where we have to evaluate manuscripts that differ wildly in their level of transparency. So let's imagine manuscript A, where the authors are really transparent. They tell us, maybe they pre-registered, we can see what was planned, we can see that they deviated from those plans, they're honest about all the analyses that didn't work out. And because of that transparency, we see that their conclusion is based on one analysis path that is really not robust. If you alter it in any way, we see that it doesn't hold up. So I don't believe their conclusion. I say, no, actually, you don't have good evidence for that conclusion. And then I have another manuscript that I'm evaluating, and the authors are less transparent. They don't share the data, so I can't reanalyze it. They don't have a pre-registration, so I can't see what was planned and what wasn't. And they don't show robustness tests, so I can't tell how robust their result is. So they present one analysis as if it was planned, and they interpret it as if it was the only analysis they ran, as if the error rates are controlled, for example, by type 1 error rates, alpha. And I'm in an awkward position, right? So I have two options. Either I give the authors of the second manuscript the benefit of the doubt, and I think, okay, let's just take their word for it. This is what they planned. There was no flexibility. They have the appropriate error rates in check. So maybe their conclusion is warranted based on the evidence. They have good evidence for their conclusion. So if I do that, that's not fair to paper A, because paper A could have done that, but they chose not to. They chose to be transparent and let me know that that wasn't the case for them. So I'm punishing them and saying, if you had lied to me or misrepresented or at least left out information, you would have gotten through, but because you didn't, because you were transparent, I'm punishing you. My other option is to not give paper B the benefit of the doubt and assume that there was flexibility, that the result is not robust. And I can tell you that's not a very popular position to take as an editor, to tell authors that I'm going to assume that things are worse than what you're presenting just because you aren't transparent. So there's really no good option as a reviewer, as an editor, or even as a reader, right? When you're trying to compare which of these things to trust, which of them to build on, which of them to cite. So everybody's just in this kind of quality uncertainty, information asymmetry state, and it's not good. It's impossible to give enough weight to the transparency that it outweighs the benefit of being opaque and of not being transparent in terms of the incentives for the researchers and authors. So for that reason, among others, we've decided at the journal that I'm editor-in-chief of that we're going to move to make transparency the default. And actually, that was a decision taken by the previous editor that we've then put into place in our term. So together with Tom Hardwick, who's the senior editor for statistics, transparency, and rigor at the journal, we wrote this editorial and we changed the policies so that now the default for authors who submit to the journal is that we expect them to share their data openly, their analysis scripts or code, their materials, and we do a computational reproducibility check before we formally accept the manuscript. We do make exceptions, so there's an asterisk next to the required transparency in this lesson because we do allow for exceptions when that's in the best interest of science, or on a case-by-case basis, we let the editor evaluate whether the reasons for not sharing are good enough and the benefits outweigh the costs. So I think that that's really important because otherwise the early adopters of transparency are penalized. There's, again, even well-meaning editors and reviewers who want to reward transparency. It's really hard to know what that looks like if it's optional. So the fourth lesson is transparency is not magic. So just because we make things transparent doesn't mean we're making them more rigorous. It's not going to be enough. So one really vivid example of this is, one of the early adopters, a journal in psychology that adopted open science practices fairly early, was starting to require authors to share their data and code before many other journals. And Tom Hardwick, once again, did some excellent meta research looking at, okay, that's great that the data are available. Can we reproduce the results in those papers when the data are available? So this is already like a select bunch of papers, right? These are papers published in a journal that was one of the first to require authors to share data. Authors chose to submit to this journal knowing that this was the policy, and they did share the data. And here's what Tom found when he and his team attempted to reproduce the results in the papers. So for about a third of them, they took 35 papers. For about a third of them, they were able to reproduce every result in the paper without any assistance. Another third, they could, after asking the authors for assistance, and about a third, they couldn't reproduce every single result despite author assistance. Now here, we're having a very high standard of reproducing every result in the paper. So some of the key results were reproducible, but not all the ancillary results. But still, this shows that just because people are open doesn't mean that there aren't any errors, right? So transparency doesn't guarantee that the work is rigorous or error-free. So that's one possible outcome of transparency, is that things get better because we detect errors, people learn how to do it better, we fix the record, etc. That's certainly the path that we hope we're on when we become more transparent, but it's not the only possible way to go when things become more transparent. The other possibility is that transparency leads us to find the same errors over and over again. The field doesn't correct, we keep doing it, and we lose credibility, right? If we're transparent and we're not doing things rigorously and we're not learning from our mistakes, we shouldn't get more credibility. So transparency doesn't guarantee credibility. Transparency guarantees we get the credibility we deserve. So good work gets recognized as good work, and shoddy work gets recognized as shoddy work. Now, guarantees is too strong a word here, so that's why I put an asterisk here, but it at least makes it more likely and makes it possible. But I think that for one experience of the replication crisis and reform movement in psychology is that there was this feeling that we were moving the goalposts. We said at first, we were like, just be transparent. We just want to know what you did. Just tell us the truth. And then we said, oh, no, actually, we're going to use that transparency to scrutinize your work and point out errors and so on. And I don't know that we could have done anything differently in retrospect, but I do think that it's something to be prepared for. If your field is not used to transparency yet, there's going to be this, it's going to be hard enough to bring people along to be transparent. And then it's going to feel like a double whammy when you say, oh, but actually that wasn't the point. The point was rigor, and transparency is in the service of rigor. And it might help us identify that actually we have some problems around rigor. There's a really nice, very short paper by Andrew Gellman called Honesty and Transparency Are Not Enough, where he says, consider the consequences for a researcher who eagerly accepts the message of ethical and practical values of sharing and openness, but does not learn about the importance of data quality. They could then just be driving very carefully into a brick wall, conducting transparent experiment after transparent experiment, and continuing to produce and publish noise. So really, transparency is absolutely vital. It's necessary for credibility, but it's not enough, and it's not going to magically make our work better. So really, if we want to have credibility, we don't just need transparency. We don't just need to say, in principle, people can lift the hood. We need to actually pair that with, I'm going to call it organized skepticism after Robert Merton, the norm, the idea that people go in and actually check each other's work, that there's an organized system of verifying and checking. So we don't just have cars that can be inspected. We have inspectors, we have mechanics, we have tools and incentives for people to do that work. If we go back to the metaphor of transparency as giving your critics ammunition, then we need to have critics who use that ammunition and who actually hold us accountable and help make our work better. And this is, I think, where things got really tough with the replication crisis and reform movement in psychology. So as hard as it was to get transparency rates up, and we still have a long way to go, I think that was the easy part. For transparency, we are making our way up the ladder. I think for organized skepticism and criticism, we're arguably still working on the make it possible stage. And this is, I think, going to be the tougher battle, but very, very important as well. And so this leads me to my next lesson that I've taken from the replication crisis in psychology, which is that journals are part of the problem. Now, this crowd won't be a hard crowd to convince that journals are part of the problem. I obviously have not given up on journals. I'm still an editor at a journal, and I really want them to do better and think that they can do better. So I'm not completely thinking that we need to get rid of journals, although I'm not against that position either. I kind of try to have it both ways, so we could talk more about that. But really, I think that what is happening is that we're kind of letting journals off the hook a little bit too easily. And when we think about the replication crisis in psychology, we often don't really think that much about the role of journals. But really, the failure of large-scale replications and other kinds of audits of the psychology literature that showed how bad things are was an indictment of journals, because journals' whole raison d'etre, their whole justification for being, is to vet manuscripts. They're helping us figure out what's worthy of our attention, what's worthy of reading. And part of that is what's high quality, right? It's not the only dimension, but surely that's assumed to be a dimension of journals' vetting and selection process. Well, we know in psychology that on at least some fundamental dimensions, journals were not doing good quality control. So famously on the dimension of replicability. So here's a very, very crude summary of some of the high-profile replication attempts in psychology. So these are multi-study replication projects. So RPP is the Reproducibility Project in Psychology, published in 2015, and then other projects, most of which focused on psychology. If we take a very, again, crude point estimate, which should be taken with a huge grain of salt, of the success rate I've updated this recently with the latest replications that I could find in these categories. It's about 45%. But again, take a big confidence interval around that. Could be quite a bit higher, could also be quite a bit lower. But even a substantial amount higher than this is still quite low, given that most of these projects pulled the target articles from the very best, highest impact, most cited psychology journals. So these are journals that have an acceptance rate of 10% or less in many cases, articles that are cited dozens of times in many cases, et cetera. And many of them we have a hard time replicating if we try to follow what they did. And perhaps even more troubling than the low replication rate is that consistently across these replication projects, the effect sizes are just much, much smaller in the replication studies. Not in every single case, but on average, much smaller. And what's interesting to note about this to me is that very often people don't pay attention to the journals that these articles were published in. So if a replication failure sticks, it might stick to the phenomenon or the original article, but it rarely sticks to the journal. And even when the replication projects targeted specific journals. So 2 of these projects targeted specific journals. So the RPP targeted 3 specific journals in psychology. The SSRP targeted 2. And sometimes I've given versions of this talk or talked about this finding to psychology audiences, and I'll ask them, do you remember which journals were targeted? For example, the RPP, right? The classic, the first big replication project in psychology that was, the talk of the field for a long time. And people sometimes can't name any of the 3 journals that were targeted by that. We don't attach this failure, this problem to the journals, even though that is their job, right? They are claiming to identify top papers. Another interesting thing to me about this estimate of replicability of around half of findings being replicable is that it's also very consistent with another way of estimating the replicability of psychology findings, which was comparing traditional articles published in traditional journals to registered reports, which tend to have less bias, right? They kind of block off some sources of bias from authors, some sources of bias from journals. And Anne Shields' work has shown that if we compare the standard literature, where about 95% of findings published in psychology are significant, statistically significant, support the research hypothesis, in registered reports, it's about 45%. So again, we don't know for sure that the 45% is what would be the true rate of positives if there was no bias in the standard reports, but it's shocking that that estimate is very, very similar to the estimate from the replication projects. So just some converging evidence. But it's not just replicability that's a problem. Journals are letting in a lot of papers that are failing on other basic tests. So for example, the tool StatCheck that Michelle Naughton and colleagues developed, they ran it on articles published between 1985 and 2013 in 8 top psychology journals, and 1 in 8 articles had what they call a gross inconsistency, which is a p-value that not only does not match the test statistic and degrees of freedom, but does not match it in a way that changes whether it's significant or not. 1 in 8 articles. So you might think, okay, well, false positives and statistical errors, those aren't the important errors, right? That's not what's most important to get right. And maybe journals are getting right the things that are important to get right. I would argue those are among the easiest errors to catch. And so if journals aren't catching these relatively objective things with pretty clear signs, then what are the chances that they're catching conceptual errors of operationalization or measurement, or causal inference errors or errors of generalizability that are, I think, tougher to catch. So to me, it worries me that, yes, these aren't the most important tests of whether a finding is important or high quality or whatever, but they're easy tests and we're not passing them. And I think this is a problem because I was looking for a good quote for this, and I feel bad attributing it to any one person because I think it's just a view that's out there. But I actually heard a dean say it last week. I won't say who, but a dean at a big university that you've heard of recently said, "We typically expect that errors will be caught in the peer review process." And I think this is a view that many people, probably most scientists, and certainly most of the public, I think, hold. And I think this is one of the reasons why I wrote an article in Wired a few years ago saying peer-reviewed scientific journals don't really do their job. I think it's reasonable to expect that they do some quality control. And I think that it's a relatively small part of what many journals see themselves as doing. which leads me to my next lesson, which is that we should expect more from journals. So this is something that we've kind of let journals off the hook. So at a minimum, journals should require the kinds of transparency they would need to catch errors. So if journals are not catching errors, it's partly because they're not asking authors to share data, share analysis scripts, share enough details about the method to catch some of these errors and so on. So at a minimum, we should expect journals to at least ask for information that they need to do quality control and then do that quality control. Now, one quote I often use when I talk about these kinds of things is this Kurt Vonnegut quote that another flaw in the human character is that everybody wants to build and nobody wants to do maintenance. And this is certainly an obstacle to getting errors detected and corrected. But it's not a good excuse for journals because that is literally their job. And so if you don't want to do maintenance, then maybe don't get into the journal editing business. And it's not the only job of journals, of course. Like, I don't mean to reduce everything to just error detection or quality control. There's a lot more that goes into editing and reviewing, but it is one of the jobs. And so to the extent that journals are asking for our trust, which is a lot, right? They are saying that they are doing a good job, they're providing a valuable service, and we outsource prestige to them. We say, okay, we're not going to judge what's high quality work and low quality work on a case by case basis. We're going to assume that journals are doing a good job, that the prestige journals, the selective journals are picking out the highest quality work. We probably should do that a lot less than we do, right? We should be reading the papers. We should be evaluating research on its own merits and candidates on their own merits. But there are always going to be situations where we can't do that and we outsource it to journals. I think journal prestige is not going to go away, but it can be earned. We can ask journals to actually show us that they're doing the work to earn that prestige and earn that power that they have and influence that they have in our fields. So we've been thinking a lot about what that means for our journal. And so we've taken some steps to try to implement more quality control, more checks and vetting along the way. So you can find this on the Psych Science website. I won't go into it, but basically we have different parts of the peer review process. We use not just external reviewers and not just the scientific editors who evaluate the work, but also the STAR editors, the statistics, transparency, and rigor editors who come in at different stages and do different kinds of checks. So we do transparency checks, computational reproducibility checks, statistical advice, things like that. So we have an amazing team of STAR editors. I don't think this is completely up to date, but this is most of them who really contribute a lot to the peer review process. And, I think this is something that I would love to see more journals implement, but it's really right now depending a lot on the amazing goodwill and efforts of these people who are doing it. Like most editors, there's not much financially in it for them. I think that's especially true of this team, who get less glory, I think, than handling editors, but they're doing super important work. And you might recognize in these faces some of the names and faces I've shown earlier of people who did meta research about psychology journals and some of the problems they have. And so that was intentional. One of my goals in choosing STAR editors was to choose people who have done work about problems in psychology journals and specifically at our journal. So people who've shown some of the flaws in the published research or even identified cases of fraud that led to retractions in our journal. So I think there's a lot that journals can do. There's a lot of people out there who do want to do maintenance, who do want to do error detection, and journals can actually bring those people on board and ask them to help before we put our stamp of approval on a paper. So which brings me to my next point, which is that we're always going to need these kinds of critics who point out errors after the fact. So it's great to bring them on board more and have everybody help out with peer review before we accept a paper, but we still need the critics to look at, we're going to let errors through, and we need post-publication critique. So peer review is not magic. It's not going to stop all problems. We're going to let errors through. It shouldn't aim to be perfect. That would be unrealistic. But then we should be very thankful for our critics. Those are the people that make it possible for us to say that science is self-correcting. So what that looks like is things like rewarding them with official roles at journals if that's valuable to them, with money, with recognition, with lines they can put on their CV, with jobs, etc. And I would say for me, the most frustrating part of the replication crisis in psychology, the part that got me most disheartened, the hardest and darkest times were when we treated our critics badly. So you might have heard some of these famous things that people were called in psychology. So these were names aimed at mostly people who did replications or other kinds of error detection. So they were called replication bullies, human scum, methodological terrorists, second stringers, destructive iconoclasts, And my favorite, because I'm not sure it's an insult, but I guess it was supposed to be, is accuracy fetishists. And so this was really shocking and dismaying to me. I thought that, yes, we had problems, but of course we were gonna be grateful for the people who were pointing out those problems. And instead, much of the reaction in psychology was the opposite. And of course, there were some people pointing out problems who were unprofessional, who crossed the line, and I don't condone that at all. But the people doing good work, who we should be thankful for, were painted with the same brush. And in the beginning, a lot of that was using the argument that we can't have unmoderated criticism, that we need gatekeepers of the criticism. So, for example, there was a column in our newsletter that argued that the criticism should go through gatekeepers. So this person said, to be sure, constructive critics have a role with their rebuttals and letters to the editor, subject to editorial oversight and peer review. And I think this is a problematic position to take. And I would encourage other fields who are facing or will face similar crises not to take this position. Do not limit your critics to only gate-kept, peer-reviewed, moderated forums. And yes, that means there will be messy things, and we need to make sure that we crack down on unprofessional behavior and we don't tolerate it. But that is not the same as making everyone go through a formal peer review process at a journal before they can express criticism. And one reason for that is from other meta-science work supervised by Tom Hardwick but led by Annie Wamand, where we looked at the policies that journals have for post-publication critique in psychology. And so what we found is that about 33% of prominent journals in psychology, so this is again high impact factor journals, have an explicit policy that they accept post-publication critique. Most of them have implicit policies that they don't. Very few have explicit policies that they don't. If you're curious, it was slightly worse when we took a representative sample of journals. So the higher impact factor journals are slightly more likely to have a policy that they allow for post-publication critiques. Many of them had a limit on how long those critiques could be, and some of them had limits on how soon the critique had to be submitted after the original article that it was critiquing. So there's still quite a few restrictions. But the policies aren't great, and we also looked at the prevalence. How often do journals actually publish critical commentaries? And it was very, very rare. So we cannot ask the critics to go through formal channels when those formal channels don't exist, or when they exist, they're not actually feasible to use. And we also know from a lot of anecdotes in psychology's replication crisis that when critics have tried to go through the appropriate channels, have alerted editors or supervisors or universities about problems, that has massively backfired on the critics. So that is a huge risk and a huge cost for critics to take on themselves to go through formal channels. So here, for example, is a blog post from Zoe Ziani, who was one of the whistleblowers in the Francesca Gino case of fraud. And Zoe writes, after she had discovered problems in Gino's work, what should happen then if science were, as many people like to say, self-correcting, is that after a peer review of some form, my criticism would get printed somewhere and the field would welcome my analysis in the same way it welcomes any other paper, another brick in the wall of scientific knowledge. And then she goes on to say, anyone who is engaged in data forensics knows that journals and institutions are strongly motivated to ignore evidence of fraud. And so if you don't know, what happened in the Gino case was that Zoe stayed anonymous for a while, and other whistleblowers came forward and shared with Harvard their concerns about Gino's work. And she was removed from her job at Harvard, and then she sued Harvard and the three whistleblowers who came forward with a $25 million lawsuit. So that, again, very strong message that whistleblowers, people who detect errors and report them and so on, there's a huge potential cost to them. Luckily, the lawsuit against the whistleblowers was dismissed by the judge, and I think it's really useful to look at what the judge's decision cited. So in this case, the judge, this was in Massachusetts in the US, cited another decision in a previous case by another judge, and in that previous decision, it was about Dilworth was an engineer who had sued someone for criticizing him, and Dilworth was saying, this was defamation because I'm a private citizen and these people are publishing criticisms of my work that are not true. And the judge said, Dilworth is an obscure engineer. Yes, that's true. But anyone who publishes becomes a public figure. By publishing your views, you invite public criticism and rebuttal. You enter voluntarily into one of the submarkets of ideas and opinions and consent, therefore, to the rough competition of the marketplace. So we, as a scientific community, should not be taking a harsher line on critics than the law, at least in the United States, takes on what is acceptable criticism. In fact, we say, right, that science is self-correcting. We say that we want to find errors in our work, so we should be encouraging criticism that is professional and respectful. Then the eighth lesson I have is that a crisis can look a lot like normal science. And this, again, is one of the more worrying things and one of the hardest things I felt I had to navigate in psychology's replication crisis. And this was that, after the replications were failing and things errors were becoming obvious, and the first wave of defense was, no, there aren't problems. Then the second wave of defense was, of course there are problems. It's normal for there to be errors in science. That's just how science works. This is normal science. So I was part of a National Academy of Sciences study committee on reproducibility and replicability in science. And one of the challenges in that committee was that we were supposed to write a report for the public, mandated by Congress in the US, about errors in science and whether or not there's a replication crisis in a field, how would we know, and so on. And in one of the early chapters, the committee had written about how errors are normal in science, and one of those lines was, the advent of new scientific knowledge that displaces or reframes previous knowledge should not be interpreted as weakness in science. That's completely reasonable. I agree with that in the abstract sense. What I struggled with, and one of the reasons I ended up removing my name from the report, is that I really wanted us to grapple with, when is it not normal science then? Because we can't ask the public for a blank check and say any kind of error. We can repeat the same error over and over again. We can make totally avoidable errors, etc. It shouldn't be the case that we can say all of that is normal science. So what is the difference between normal science and a crisis? And I don't know the answer, but I know that we need to grapple with that question. We need to have a good answer, because it's not okay to just say all errors are normal. And we saw some of this in psychology's case. So around a few years earlier, in the kind of the height of the replication crisis in psychology, some very, very big names in psychology wrote an annual review chapter about the state of the field. And they wrote, all of this replication crisis is normal science, not crisis. A replication failure is not a scientific problem. It's an opportunity to find limiting conditions and contextual effects. Of course, studies don't always replicate. Again, I completely agree. In a really healthy science, not all studies will always replicate. There will be contextual effects and limiting conditions. So how can we tell the difference between that and things being terrible, right? If this could excuse any level of irreplicability. So we have to have a way of knowing the difference. Otherwise, we risk being in this cartoon. And we often see this panel of the cartoon, but we should also keep in mind how it ends, right? We don't want to be in this world and be telling ourselves that all of this is normal science. So this is a really, really hard question to answer. And the best answer that I can think of, which isn't a very satisfying one, is we have to look for concrete signs of a commitment to self-correction, not just lip service to self-correction, but what can we point to and say, this right here, this shows our commitment to self-correction, to finding errors and fixing them. And the best I can come up with is these two things. To find errors and fix them, we need transparency. So the errors need to be detectable, and we need to bend over backward to be as transparent as possible. And we need people who are going in and actually checking things. And we need to not punish those people, but even reward them. So what does that look like? Well, I don't think we can just rely on individuals who are going to volunteer for this role, right? Especially given the costs and so on. And in fact, we know that individual scientists are not particularly noble. We're not going to just sign up to have our errors exposed and be happy about it. And the public knows this too. So even though public trust in science is really high, so these are the green bars here, and this is in the US, but it's true in many countries in the world, that the public has as much trust in scientists as they do in almost any other group. But that same group of people, the public in the US, also say that scientists across medical, nutrition, and environmental sciences are not particularly known for admitting and taking responsibility for their mistakes. So only about 10 to 15% of respondents think that scientists admit and take responsibility for mistakes, which is correct. Scientists are human. Humans famously do not admit and take responsibility for mistakes. So how are we going to have self-correcting mechanisms if we're all human and humans don't like to self-correct? Well, one answer from the philosophy and sociology of science, which was echoed by a psychology methodologist decades ago, is that this is a social process. So science is trustworthy, and that dependability comes from a social process rather than from dependence upon the honesty and competence of any single experimenter. Organized distrust produces trustworthy reports. So what does organized distrust look like? It's, again, having transparency and having systems in place and very concrete things we can point to, not just peer review or something abstract like that, but really concrete things we can point to. So I think we need more skepticism and it needs to be more organized. And so I have one example of what that might look like. So in the social sciences, this actually was started by some economists, a group called the Institute for Replication, where they're an independent group, not affiliated with any particular journal, but they audit journals. So it started with economics and political science journals, where they would do audits of articles published in any given year in any given journal. They would audit a number of articles and attempt to reproduce the results and sometimes do generalizability tests and things like that. And then they publish their reports as a meta paper at the end of the year that's specifically about that journal. How is that journal doing? So I think that's a great example of kind of putting our money where our mouth is. If the field is supporting this, if we're funding it, if we're publicizing it, and we're, rewarding and valuing the work that these people are doing, that's a good concrete sign of a commitment to self-correction. It requires transparency. So they can only do this for journals where the data and code are publicly available. And it requires organized skepticism. It requires structure, infrastructure, and value that we place on this work. And about 2 years ago, they started adding Psychological Science as one of the journals that they're auditing, and Nature Human Behavior, so 2 journals that publish psychology articles. I've also joked that we need other kinds of infrastructure too. So in psychology, for example, we have the Psychological Science Accelerator, which is this great thing that does very large scale studies. And I've argued that in addition to things that accelerate science, we also need places to take broken science and have a mechanic fix it. Or it doesn't have to be stuff that we think is broken, but anything that we're putting a lot of weight on. If our field is about to build on this and invest a lot, or we're about to roll it out as public policy, or tell people that they should change how they approach their relationships because of our finding, we need to stress test it. The same way you would take a car to a mechanic before you would go on a long road trip. If you're going to take a finding to the bank and really stake your field's reputation on it, then maybe have people stress test it, have a red team go at it. So having institutions like that, I think, is the way that we know whether we're not in normal science and not in a crisis. And that brings me to my last one, which is my latest hobby horse, which is meta-analysis is not magic. So I got to this kind of I think it's the natural next stage after you've tried to fix research practices, you've tried to fix peer review, you've tried to fix post-publication critique, and then you think, okay, well, what's the next thing that we can do if we want to stop shoddy results from having an impact? And that's, I think, changing how we do evidence synthesis and systematic reviews. And in psychology, that basically means meta-analysis. In the interest of time, I'm going to skip over these slides, but I encourage you, I'll post these slides publicly, to read these couple of papers. So one, comparing meta-analyses to replication projects. The punchline is the meta-analyses way overestimate the effects compared to these like rigorous replication projects. The other is a paper and some blog posts by the same data collada, Simonson, Simmons, and Nelson, about some common problems in meta-analysis. So to summarize, there's a few lessons about transparency, that it's necessary, it's hard to change, we should move to making it required as soon as possible, and it's not magic. It's not going to fix everything. It doesn't make things rigorous, but it's a necessary but not sufficient condition for credibility. Then that journals are part of the problem, but we can expect them to do better. They can do better. And if they're going to control who gets prestige, then they should have to earn that power. But also, even in the best case scenario, peer review is not magic. It's not going to catch all mistakes. We need post-publication critique, and we need to reward the people who do it well. Don't be comforted by the fact that the errors that your field is seeing could be explained by, contextual effects or other kinds of normal science problems. That's also what a crisis looks and feels like in the beginning. And I would, make sure that you have the safeguards in place that you would catch, your field would catch itself if it was in a crisis. And don't rely on evidence synthesis or meta-analysis, those kinds of things, because if there's problems in the primary literature right now, the way we do evidence synthesis is not going to catch and fix those problems. So to summarize, improving science is hard. We're trying to get ourselves to do research better, to vet research better in peer review, to correct research better after it's published, and to synthesize research better. It's all really the same problem, right? If we knew how to do any of this really well, we would catch it at all of the stages. But it all comes down to just making sure that we have the incentives in place to catch ourselves when we inevitably make mistakes, and making sure that we make that as easy and as rewarding as possible. Or to summarize it with a tweet from James Heathers, maybe my favorite tweet of all time: science is self-correcting, sure, when we correct it, not because of magical progress. Thank you.
Thank you very much, Simine, for your presentation. We will now take questions from the audience. We will end the session at 5 p.m. Because it's getting pretty late for Simine. So we have 12 minutes ahead. So if you want to ask a question, just write it in the chat. I will start reading the questions. So I will. So the first one I found is from Grace Edwards. One of the barriers to sharing is the format of sharing, bits, formatting, etc. Do you think we should continue trying to conform to a formatting approach or releasing data in any format to allow maximal sharing?
That's a good question. I think it's going to be a case by case thing and also maybe a case by case in terms of timeline thing that maybe in the beginning for fields where sharing is relatively rare, we don't impose a lot of requirements or structure initially. And then as people get used to, the baby steps of sharing, the initial stages, then we start imposing more structure, more formatting, and so on. I don't know how to avoid going through those kinds of growing pain phases. I think also there's a lot we can learn from fields that have been doing it for longer. So for us in psychology, a field that we look to in terms of data sharing is economics. So they've developed a lot more guidelines and principles around README files or formatting or things like that. But there's some things we have to adapt. Some things that are true in econ just don't work in psychology and vice versa. But still, I think there's a lot that we can adopt and learn from fields that are further along. But I don't think there's a simple answer to that question.
Thank you. Could you provide some examples of when it's best to require transparency from authors?
To not require transparency, I think is the question.
Not, yeah, a question from the audience. Sorry.
Yeah. So in psychology, for example, there are cases where there's really sensitive information in the data set, information about diagnoses or other things like that. And then the risk of re-identification of participants might be high enough. Even if we try to de-identify the data, there's always some risk. And in some cases, we decide that the risk is too high and it's actually in the best interest of science that we not make the data open, because otherwise it would be impossible to study that topic because we can't ask participants for their trust if we don't protect them. So that would be one example. And I think, for example, in ecology, there might be things about endangered species and their location, if a data set could make that known, and there's poachers or something like that. So I think there's a lot of different probably reasons, but I think we just have to think about what would the long-term effects be on science if we required this data to be open? Would it make people, stakeholders that we care about lose trust in science? And if so, then that might be a good reason not to require it to be open.
Are stats reproducibility editors volunteers? Are they paid? And if paid, where do the funds come from?
Yeah, that's a good question. Some are volunteers, some are paid. So when I invited the first batch, we prioritized giving stipends to the earlier career people, and I asked the more senior people if they would be willing to do it without a stipend. Some of the money comes from APS, the society that owns the journal, so they pay a stipend. And I've been lucky to be able to supplement the pay with some funding that I have that is earmarked for error detection and things like that. That's not sustainable. That funding is going to run out, but I've been lucky enough to be able to do that for a little while.
A question from Melanie. Thanks for your insight. What are your thoughts on the role of funders, specifically in their review of project plans before the projects are funded?
That's a good question. Because I work so much with journals, I don't think that much about funders. But I mean, the same kinds of issues that come up in evaluations for jobs or promotion are relevant too. Like if you are evaluating candidates, or in this case, applicants for grants, based on their track record, and you're weighting which journal they published in, or how flashy their findings are, how many citations their findings got, how much media attention they got, you might be incentivizing the wrong things. So there should be a way to also make sure that the research is rigorous and transparent and so on, and that weighs into the evaluation of the applicant. There's also other things funders can do, like pairing with journals to do a registered report style project. So if someone's proposing a study and it's an important study where the outcome will be interesting regardless, then they could combine the funding with an in principle acceptance from a journal, make sure that it's gone through peer review at that journal, and so on. So I think there's a lot funders can do probably.
A question from Thomas. Is there any reason why registered reports are not the only allowed piece of work to be submitted in journal?
Yeah, I think so. I think there's a couple of reasons. One is that there are sometimes research questions where the answer is asymmetrically interesting. So if it's like a long shot, very low prior hypothesis, I think it's not that reasonable to say we'll publish it regardless without some preliminary data that gives you a reason to think that the prior might need to be updated. So then I guess you could say later in the research process, you could do a registered report, but in the early stages, I think it makes sense for most people to be like, I'm not interested until you give me a reason to think it's not completely implausible. And then there are other things where the process of designing the study needs to be very iterative. And so again, that might be a case where the early studies are not registered reports until you get to a point where you can know for sure what is going to be the right manipulation or what is going to be the right process or the right exclusion criteria or things like that. So those aren't saying that there's no room for registered reports in those kinds of research, but just that it's not across the whole research life cycle that the registered report format works.
A question from Denis. How can rigor, transparency, and reproducibility be attractive for authors in a system where many evaluation committees still favor and mostly rely on publication number and high impact factors?
Well, one answer is that the high impact journals could start caring about rigor and transparency and reproducibility, and then those things would align, right? I mean, I feel like that's an answer that in psychology, at least, we mostly don't talk about that possibility. We say we have to like stop journals because they don't select on the right things. It's like, okay, but also we could ask journals to select on better things, and we could stop valuing journals that don't select on those things. So that's hard to do, right? You can't just opt out of caring about a journal if you need your students need to get jobs in that field, et cetera. If other people value the journal, it's hard to just choose to not value it yourself. But one low-hanging fruit is your review labor. So that costs you nothing to not review for journals that you think are selecting for the wrong things. So start with that. Start with reviewing only for journals who are aligned with your values. And if we all do that, it will be a big, big problem for the journals that are not aligned with our values. We can still submit there if we feel like we have to. We can still, read their papers and cite them. And if we feel like it would be too high of a cost for us or for our students if we don't do those things, but we don't have to review for them.
A question from Susanna. Some of this feels like the tools for all the post-publication checks are things we need to do as researchers and possibly are not doing systematically. Is that
Yeah.
fair?
Yeah, so that's kind of what I was saying at the very end when I was saying, the kinds of things that I wish people did when they did a meta-analysis is like catching problems with the design and asking themselves, is this causal inference really valid? And is this a good measure of this thing? Really, that's what we should be doing post-publication critique. Really, that's what we should be doing during peer review. Really, that's what we should be doing when we're designing our studies, right? So it's all the same problem, but we're never going to get rid of the errors all the way at the root, right? We're never going to be able to train everybody to only do good research. And there isn't only one kind of good research. Anyway, there's always going to be some disagreement. We need some diversity and plurality of what people think is good research. So there's going to be stuff that's published that later we realize, oh, that was wrong. That was a bad way to do it. So that's why I frame it as post-publication. We need kind of all the stages of verification and vetting. But really, yeah, they are all the same tools, the same training, the same kind of critical thinking. Yeah.
We have another question from Afaf. If we take humans as a system that you disturb once, you observe it, how can we have not biased results despite the p-values?
I think that one is above my pay grade. I mean, it's certainly an issue for some kinds of human phenomena, but I think not all kinds. So not everything changes once you observe it to a degree that it becomes not the same phenomenon. But we also in psychology try to sometimes measure that, which I know can sound like a paradox, but for example, in my other world as a personality and social psychologist, we had a paper where we used a method called experience sampling, where you beat people and ask them how they're feeling right now. But we also had people wear a recorder, so we could measure what are people doing when they're not answering to get a sense of like, are we changing what people are doing by beeping them and asking them to answer a questionnaire? So there are some ways to try to get around how much like actually measuring things changes the phenomenon that you're trying to measure.
So a question from Dominique. Simine, I agree with pretty much everything you said, but I am increasingly worried by the results of many analyst studies showing that lots of people reanalyzing data with no incentive to find a particular result often yield wildly different effects, size and direction. Any thoughts on that, implications of these findings?
Yeah, I mean, I think one implication of the finding is that we should just have a lot more humility in interpreting our results, at least in the social and probably biological sciences. I think there's just a lot more noise in those fields. And so, yeah, any one result might not hold up within that data set, much less across other data sets and so on. So I think we just need to make less grandiose claims from individual studies or individual analyses. ideally, we would also be able to represent the multiverse of possible results in a way that's succinct and doesn't make the paper unreadable and all that. I think that's a challenge. There's some proposals to do that across, like have commentaries on papers where different people reanalyze the data in different ways and kind of give a sense of the multiverse, not just in one paper by one team of authors, but doing it in a slightly more adversarial or at least diverse group of authors kind of way. I think that would help. I think we really haven't fully appreciated just how messy everything is and how much more uncertainty we should have around all of our estimates and findings.
Another question from Thomas. It looks like funding agencies are okay with the situation where more than 60% of the research they fund is not correct. How is it possible? What could be the funding agencies do to change the situation?
I have no idea. That's such a hard question. I mean, I guess my impression is that at least I'm more familiar with the US funding landscape than Australia. I've been here for almost 6 years, but still haven't quite figured it out. Um, my sense is in the US, the funders actually do care quite a bit. Like in many cases in psychology, sometimes the pressure came from funders before it came from journals or professional societies. So there are some ways in which funders are kind of ahead of the curve and bringing along other actors and gatekeepers in the system. Not always, but quite often.
And the last question from Fivos. One barrier I keep coming across relates to the hierarchy of science. For example, a lot of early career researchers might want to implement more open and transparent science. However, they find resistance from advisors, supervisors, etc. Similarly, the pressure of producing in order to eventually get a faculty position might require us to take the path of least resistance, e.g., skip registrations, etc. Any thoughts or advice for ECRs who might want to change but find resistance?
Yeah. If you're in psychology, blame me. If you're in another field, find other editors or like senior, relatively high status people who are saying, we want to see this kind of change and we will look more favorably upon your job application or your paper or your grant if you're engaging in open practices, if you're showing your work, if you're using rigorous methods, etc. If you can find like people that your advisors or collaborators care about who are saying these things and really consequential things like journal policies or funding agencies or job ads that say we're looking for someone with a track record of doing this kind of research, then you can show your advisors that and say, look, maybe these people are crazy radicals, but this is what we have to do if I want to be competitive for a job. So kind of blame the more senior people if you have any in your field that are saying these things. Use them for cover. That's what we're here for. I mean, we're doing these things partly so that we can change the incentive structure. And very often when I'm editing a paper, if I find flaws or ways in which it wasn't accurately reported and so on, I write my decision letter in a way that I imagine that one of the authors on the paper was an early career researcher who wanted to do the right thing and was trying to convince their co-authors and lost that fight. And so I want to vindicate that co-author. So that's, I hope that those of us that are kind of more on the front lines and have less to lose and can be more outspoken about it can help by providing cover when you're in those situations.
Okay, thank you, Simine. So it's now 5 p.m. and that means it is time to end the session. Thanks again, everyone, for attending the webinar and for your questions. And thank you again, Simine, for your presentation and the nice discussion.